We're going to be working with authors and courses in the demo project. You're looking at the course library solution now, opened in Visual Studio. There's one project in there, courselibrary.api, which contains our API. Let's start at the bottom layer, the data access layer. I'm using Entity Framework Core, so I've got a DB context, course library context. As this is Entity Framework Core, a multitude of database providers can be used. I chose to use SQLite for this course. And that's on purpose. Using SQLite means that this code will work regardless of the operating system you're using. Some of you may be on Windows, others may be on Mac or Linux. SQLite is not tied to any specific OS. But if you ever want to switch to another type of data provider, you know that that's easy to do with Entity Framework Core. Two entities have been added, the author entity and the course entity. An author entity is modeled with common fields like ID for the author ID or key, first name, last name, date of birth, and the main category of courses the author creates. It also contains a list of courses. Such a course is modeled with a few fields you might expect from a course. An ID, obviously, but also a title and a description and a link back to the author the course belongs to. One author can have multiple courses, but one course always belongs to exactly one author. Let's switch back to the DB context. It tracks these entities and exposes them as DB sets. Like that, our code can easily interact with them. In the onModelCreating method, I added some dummy data to start from. There's a set of authors that seems to contain quite a few pirate-like names, and there's a set of courses relating to these authors that also seem to deal with pirate-like subjects. If we scroll down a bit more, you will notice one small workaround here in the onModelCreating method. That one is there to ensure that SQLite can work with date-time offsets, which it doesn't support out of the box. Anyway, that's it for this DB context. Our controllers, an author's controller and a courses controller, interact with this DB context through a repository. You can find that repository underneath the services folder. Looking at the repository contract, you can see that it contains some common methods you might expect to be used by an API that exposes authors and courses. We've got methods here to get courses or get one specific course, to add one, update one, or delete one, and likewise methods for interacting with authors. Let's have a look at one of those controllers, the author's controller. It depends on the repository, as mentioned. Important to notice is that the entity classes are not directly exposed. Instead of that, DTOs are exposed to the outside world. You can find those DTOs underneath the models folder. And this is essential. The entity model is different from the DTO or outer-facing model. Throughout this course, you will learn why this distinction is so important. Automapper is used to map between entities and DTOs. You can find the related Automapper profiles underneath the Profiles folder. This API works, but some of you may already notice a few things, like inconsistent naming of routes, or rather weird methods being used, like post for getting authors. That's on purpose. As mentioned, we are starting from a more or less okay web API that is functional, but it's not one that's built with best practices in mind. We will fix that during the course. In the program class, ASP.NET Course IOC container is set up and the request pipeline is set up as well. I created two extension methods to this veil to keep our code a bit more organized: configure services and configure pipeline. This feels cleaner than just putting everything directly in the program class. Let's have a look at that configure services method implementation. The required services for working with controllers are added to the IOC container. Our course library repository is added with the scope lifetime. The context is set up and AutoMapper is configured. If we scroll down a bit to the configure pipeline method, we see how the request pipeline is set up. All in all, this isn't that special yet. This should still look quite familiar to most of you. Let's switch back to the program class. One additional point of interest I'd like to focus on here is the call into reset database async. This ensures that the database is recreated whenever the application is started. You can have a look at the implementation if you want in the Startup Helper Extensions class. Resetting or recreating the database whenever the application is started is not something you'll typically want to do in real life, but it's definitely something that comes in handy while working through the demos and following along. There's no need to be afraid of making a mistake that may result in corrupted data, as the database, including dummy data, is reset on each run. So this is what we're starting from. If this feels familiar to you and you already understand what you've seen, then that's great. You're ready to continue with this course. However, if all of this feels like a little bit too much or some parts don't feel familiar yet, I'd suggest having a look at my ASP.NET Core 6 Web API Fundamentals course first. We will interact with our API by using Postman. Let's look into that in the next demo.